In this example, a student dissolves 10.5 grams of ammonium nitrate, this is ammonium nitrate, in 225 grams of water in a coffee cup calorimeter. The temperature changes from 25.8 degrees to 12.6 degrees. Calculate the change in enthalpy in kilojoules per mole of ammonium nitrate. Assume the specific heat capacity is that of water, 4.184. So we are looking for Q reaction, which is equal to negative M C sub S delta T. So in this case, we have the mass is going to be the total. So you add it together, 10.5 plus 22.5. No, that's not the right value. 225.0. And that gives you a total mass of 235.5 grams. C sub S is equal to 4.184 joules per gram Kelvin. And delta T is your final temperature of 12.6 minus your initial of 25.8. And that gives me negative 13.2. So now we just plug these values in. We have negative 235.5 grams times 4.184 joules per gram Kelvin, multiplied by negative 13.2. And when you plug this in, I get positive 13,006 joules. Now this is equal to Q reaction, but the question asks for the change in enthalpy, which is delta H, in kilojoules per mole. So Q reaction, this is the heat per this reaction, but it's going to ask for it in kilojoules per mole. So we don't just convert to kilojoules, we need to add in the per mole part. But how do we do that? So it turns out that this value is per 10.5 grams. So if we could figure out how many moles that was, we could convert this into kilojoules per mole. So if we take our 10.5 grams and divide by the molar mass of 80.06 grams and 1 mole, I get 0.131 moles. So this tells us that this happens. So we have positive 13,006 joules per 0.131 moles. We still need to convert to kilojoules, so divide by 1,000 joules and 1 kilojoule. And then this gives me positive 99.2 kilojoules per mole. So in this calculation, you just need to remember that Q reaction is per what's in the sample. And when you divide by the number of moles of that, it allows you to convert to kilojoules per mole.